to the topic of different expression of concentrations, and we will start with normality. So a while ago, we give you one example that was very complicated, right? Now this one is not complicated, but you need to analyze in a short way how to solve the problem. Okay, let's say I have a problem that goes like this. Again, fabricate a problem. Okay, so what is the normality of a solution? Okay, is the normality of the solution. Okay, that contains, let's say, 1.5 grams of calcium hydroxide, right? Calcium hydroxide, that's the 2 family, group 2A, right? Okay. Then that dissolves in 850 ml. Okay. Check the grammar. What is the normality of the solution? What is the normality of the solution that contains 100 grams of calcium hydroxide that dissolved in 850 ml? Okay, so it's correct. The first way to solve this one is get the molarity first and then solve for normality. So this is the first step. Get molarity first. Okay, and then solve for normality. Okay. The second one is to obtain the equivalent weight of solute. Okay, equivalent weight of solute. Then substitute this to the formula in terms of equivalent weight of solute in normality. So normality is equal to EWS over L. So the unit will be equivalent per liter. Okay, so equivalent weight of solute. Okay, third method, we have the number of equivalents, equivalent lang siya. Okay, or equivalent. Number of equivalent, or let's say equivalent. Okay, equivalent alone. Or equivalent lang siya. And then after that we say normality is equals to the number of equivalent. Okay, over liter. So this will be the second version. Okay, so there are two versions of the formula. First, equivalent weight of solute per liter of solution. Second version is the equivalent over liter or number of equivalents over liter. Now we go first to solve number one, right? Nga palangga klaro, di ba? Okay. Very clear. Oh, bongacious. Okay. Molarity. What is the formula of molarity? Okay. Is equals to the moles of solute. Okay. Over the liter of solution. Liter of solution. Okay. And then moles of solute. Our solute here is, of course, calcium hydroxide. So it's going to be moles of calcium hydroxide. Okay. And then liters of solution, then liters of solution, of course. Meaning calcium hydroxide plus water. But I just have to put solution because it's understood. Okay? Like that. Now, identify in the data what is the given so that we can substitute directly. So we have 850 ml. This is for solution. Yes. It's not for the solvent. So we have the solution. Check. Do we have the moles? So we still don't have the moles. So if dealing with the most direct way is to relate that to the molar mass. Okay? So that we can solve for the moles. So molar mass Memorize this guys, put this in your brain cells because always like this in chemical engineering, especially general chemistry. Maabot pag yun siya sa physical chemistry, thermodynamics, unit operations, like that. Okay, so molar mass, okay, is equals to the mass, okay, over the number of moles. And since we are dealing with calcium hydroxide, then these are all calcium hydroxide. So molar mass of calcium hydroxide. So technically, molar mass is the same as molecular weight. Okay, molar mass is equals to molecular weight. Para di maglibog. Okay? Molecular weight. Meaning to say equal, similar. So take note, this is the K point. Molar mass is equal to the molecular weight. How can we compute for the molecular weight? Is to sum the individual number of atoms. And this is the molecular weight. Atoms, yes. Okay? Atoms because we need to consider the subscript and the moles, right? So if we have calcium hydroxide, I have no space already, guys. So calcium, based on my memorization, ay nako. Wait, sodium 23, chlorine 35 to 35, sulfur is 32, oxygen is 16, nitrogen is 14, like that. It's gonna be 40 point something. Yes, I think 40.08, like that. Okay, let's try, let's look for the periodic table if it is correct. Group 2A. Oh my gosh, it's perfect. Okay, 40.08. Okay, and then oxygen is 16 mga palangga. Hydrogen is 1.0008. Okay, this is the atomic weight of each element in a compound. Then if we have subscript, multiply that. Okay? The parenthesis mga kapatid is both elements are to be multiplied by 2 because this is belong to the 2. Okay? So 2 times H, ganon. So 2 times 1.08 and then oxygen also 2 times 16, ganon. But for calcium, no need because this calcium is not included in the parentheses. So 1 lang siya. So 40.08 times 1. Oh, ganon. Then total this one, this will be your molecular weight. Okay? Or molar mass. Okay. So, molecular weight, molar mass. So 2 times 16 mga palangga is 32. 32. Okay, ganon. Then this one is still 40.08 because this is 1. Okay? Then 1.008 times 2 is gonna be hydrogen, no, mga palangga. So 2 times 1.008 is gonna be 2.016. Total this one. Then we will erase because I have no space. Wala tayong space na titira, guys. Okay? Oh my gosh. So 40.08. 40.08 plus 32 plus 2.016. Wait, 40 review 0.08 plus 32 plus 2.016. We have 74.096. Okay, again, review properly. 40.08 plus 32, okay, plus 2.016. 74.096. 74.096 grams per mole. So this is our molar mass. Okay? Now, we have the molar mass, check. We have the mass which is given, 1.5 here, and then solve for the number of moles. The number of moles is equals to the mass, which is 1.5 grams of calcium hydroxide over 74.096 grams per mole of calcium hydroxide. Okay, cancels both gram. What will be left is the number of moles. So this answer will substitute here so that we can get the molarity. Okay, calculator please. Okay, so 1.5 divided by 74.096 equals to, we have 0.0202. Okay, this is our number of moles, 0.0202 moles of calcium hydroxide. Okay, substitute that here. Okay, erase the other data so that it can be accommodated. Okay, ganon. Okay. Erase mga palangga. Okay, ganon. 0202, no? Okay. So substitute here. So 0.0202 moles and then liters of solution. So liter, volume of the solution is mentioned also in the problem, which is 850 milliliters. But take note, it doesn't agree with the liters. Then you have to convert that to liters. 1 liter is equals to 1000 milliliters. So move 3 zeros to the left. 1, 2, 3, 8.50. 8.50 liters. So our unit now will be moles per liter, that is molar. Okay? We have now molar. Okay. 0.0202 divided by 0.850. I have here 0.0237. 0.0237 molar, or shall we say moles per liter, just the same, okay? Moles per liter is for the purpose of dimensional analysis, conversion way of solving the problems. Okay, but molarity is not so because it's specific. No need. It can be applied only in, in chemical equilibrium. Okay, topic. Okay. Now like that, we have now the molarity. So we need to get the molarity first and the normality. Okay. How can we compute for the normality? Okay. In terms of molarity. Okay? Of course. This is computation of the normality in terms of molarity. Okay. So the formula for that mga palangga is number 1. Take note. Take down notes mga kapatid. Okay? Like that. So this is gonna be normality is equals to the molarity, capital M, times the replaceable OH negative or the H positive. But take note mga palangga, this is calcium hydroxide. So this is replaceable OH ion. Okay, times OH negative. Okay, the replaceable OH ion is also called equivalent. Okay, equivalent per mole, something like that. Okay, so this is our formula. So we have the molarity is equals to 0.0237 molar. Since this is conversion, we need to use the moles per liter. So moles per liter times OH. Now we need to discuss properly why, what's the number we will multiply. Because some students, me also before, I'll just memorize. Okay? I don't really get exactly why it become like that. Because normally, true to the topic is 80% up will be based on the charge. But what if it will be changed when it reacted to other compounds or other substances in aqueous solution? So we should know really what's going on. So, muna siya natabo. Okay? So I'm going to compute ang OH. Now, let's do the chemical bonding or chemical reaction by Arrhenius theory so that we can solve for the OH negative. Di ito ikalit, just like before, when I was a student, ikalit naman sa mga maestra. Okay? If you say, there's a 2 there, 2, like that, and then the students don't know where that 2 all about. Okay? As long as they know that this 2 is the charge. And then, we just memorize that this is 2 times 2, 10. Boom! Ganon! But we don't really understand what is that all about. Okay? So that's the thing we need to emphasize to our students. Okay? Like that. So the concept behind the series of discussion in general chemistry lectures. Okay? So, welcome mga kapatid, welcome back. This is your Professor Sotero. Welcome back to our problem solving regarding expression of concentration. This is your YouTube content creator, Sotero. Ciao. Okay, now we have how to compute this one. Let's erase this other chuva-chucho. Okay, because we cannot accommodate the discussion properly because your whiteboard is very small. Mga palangga. Okay, I need a very wide screen or blackboard or whiteboard for my elaborative discussion. Wow, elaborative or detailed. Okay, now we have calcium hydroxide. Now, we add calcium hydroxide in water. Sorry, sapid. Calcium hydroxide plus water. Okay, because it is solution. Okay, so it's understood to be water. Okay, not the other solvent. Now, this is gonna be calcium hydroxide. Okay, plus water. Ganon. So what will be the expected product for this? Okay, in this situation, okay, in this kind of reaction, in this normality, molarity, we will try only to get the, for this, the H, the OH, like that, okay? Now, since we introduce the H2O, we need to dissociate the calcium hydroxide to water. Dissociation, so that we can determine the ionization of calcium and hydroxide in the water if it is really completely ionized, like that, ionization, okay, something like that. So it will become now like this, calcium hydroxide positive 2. Why I put positive 2 again? What's theory all about for this? Because when you add a water, it will be charged already. That's why there's a positive at the top. Okay? If there's no introduction of solvent or waters, so there will be no charge. Okay? So it's still a neutral compound. Like this. Water has no charge at the top. This is a neutral H2O. Since you don't have to put neutral over and over again, that's understood. Okay? That's why the oxidation state of H2O as a compound is always 0, or the oxidation number. Okay? So that you can compute the individual oxidation number of hydrogen and oxygen. Calcium hydroxide also has no charge. It is still a compound. Neutral compound, again, with a charge of 0. And what's this 0 all about? These are all neutrons. Okay? Neutrons. Because inside the nucleus, neutrons plus protons are bonded together. Okay? And you remember that one, mass number is equal to the mass of the protons plus the mass of the neutrons. Like that. So more or less they behave in the same characteristic, not negative. Okay? So they are completely like a jowa. Okay, manag-uyab sila sun sa nucleus. And then, sa electrons, nasuya siya. In fairness, ganon. Diba? Nag-uyab si protons o si neutrons. Okay. Okay, then si electrons, kabit. Sorry. Kaloka. Charif. Okay, and then hydroxide negative. Hydroxide negative. Ano mo guys? No. Hydroxide negative. And then we have 2 mandriari, guys. Okay? You will never put the 2 in the subscript. Why? Because there's no OH2. It's never. You can never see a chemical OH that the 2 is in the subscript. Nothing. Okay? Nothing. Ganon. O diba nakakaloka? May ganon. Okay? And then, so you put the 2 beside the OH. It will become the coefficient because from the theory, the atom is coefficient or the mole times the subscript of individual element. Okay? And here, OH, the subscript, parenthesis, subscript 2. And then split that out. 2 times oxygen. 2 times hydrogen. 2 times 1 for oxygen. 2 times 1 for hydrogen. Since we consider it here as a 1 hydroxide, so no need to break because 1 hydroxide alone we consider as one functional group. Okay, so we will just say 2 times OH, negative. Do not forget the negative and the positive because you are charging this already. It will become a positively charged ion, and this is hydroxide, an ion. It will become a positively charged, that is cation, and that is positive 2 for calcium, like that. So you can never say that it's a cation if it will never charge. Okay, charged with D. Okay, past tense. Okay, if you will see only charge, that is only the charge individual before it table. But when you say charged, it will be introduced in aqueous solution or reacting to any elements or compounds or substances in a chemical reaction. Gets mga kapatid? O, ganon. Okay, now so we have this positive 2 for calcium and OH negative. Now, how can we determine the OH replaceable? Of course, you will not pick the calcium because that is not hydroxide. You will pick the OH negative. And what is the value of OH? So if you can multiply that up to 0.37 moles per liter. So it's gonna be 2. Okay? Actually, this is 2 times negative 1, mga palangga. But since in science or in chemistry or in physics, there's no such negative mole. It's always positive. That's why it will become 2 also. Okay, this is the correct explanation because the student, for example, it's negative 2. Someday, if you will say that always in the beside of the OH, then the students will also use every time what's beside the OH. He will become wrong. She will become wrong. So the instructor will teach that way, that the charge times the 2 of the coefficient so that they will not confuse. Because that's only good if the charge is negative 1. What if the charge is negative 3, negative 2, negative 3? So he will always memorize in the same way in this pattern. Okay, so the instructor should emphasize the charge times number of moles or charge times the coefficient of this hydroxide. Nagkataon lang siya na negative 1. So negative 1 times 2 is equals to negative 2. But since there is no negative in a chemical reaction, always positive. The coefficient of the moles, the atoms, blah, 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 blah. That's why we only use 2. And substitute that 2 here in the OH. Okay? So this is reversible OH. So times 2. And what is our unit for this? Since we know our normality is equivalent per liter. Or equivalent per liter. So if you will multiply the moles per liter to a number alone, it will not match to the unit of the normality. So you will find a way, in such a way, that the unit will become equivalent per liter. What unit of 2 will be multiplied so that it will become equivalent per liter? Ganon. Okay? So this is gonna be equivalent per mole. Okay? Why? This means in every mole of calcium hydroxide, there are 2 equivalent or replaceable OH during the introduction or dissociation into the aqueous solution, which is the water in the Arrhenius theory. Why I say that? Because Arrhenius theory, if you will introduce any compound, base, or acid to a solution or to a water, it will yield, could either be a positive H ion or a negative OH ion. And this is the example. This is Arrhenius theory of basicity or basic. Okay? You get the point. So in this topic, we apply the Arrhenius theory, not the Bronsted-Lowry acid, Bronsted-Lowry base, and not also the Lewis acid and Lewis base. But for the enthalpy of combustion, as I discussed 2 days ago, and the formation, and it's just a band chupa-chucho, diba? Average band dissociation. Use the Lewis dot structure of acidity and basicity. So basically, guys, in chemistry, if we talk about acidity and basicity, we have 3 theories to go well. It could either be Lewis theory, Lewis acid, Lewis base. Second, Bronsted-Lowry base and Bronsted-Lowry acid. And third, Arrhenius theory of basicity and acidity. And there's an application to each theory like that, and hindi ka magpataka. Okay? You get the point? So that mataas atong score sa physical and chemical principles coverage in Bachelor of Science in Chemical Engineering board examination. Right? Okay. Ganun mga palangga. Okay. Now, we have 2 equivalents per mole, and then cancels the mole, and what will be left is equivalent per liter. Okay, so 0.237 times 2. Oh, ang sabi niyo mga palangga, calculator please. Oh my gosh, I hate drugs. 0.0237 times 2. Oh my gosh, 0.0474. Nakaloka. 0.0474. Remember, this is our normality in version 1. Okay? Be sure that this is also equal to the version 2, version 3, because you are only using 3 techniques how to solve that. But we should gain and obtain the same answer. If not the same, we are wrong. Okay, so we have the first version, we obtained 0.0474 normal or equivalent per liter. Okay, like that. Some books never mention any more equivalent per liter, always normal, chuba chuchu. Okay, like that. Capital N. Now we go to version number 2. In terms, equivalent weight of solute, in which equivalent weight of solute over liter is our normality, equivalent per liter, again is in minute. Okay. How can we determine the equivalent weight of solute, mga palangga? Okay. So abbreviated as EWS. But some books also and references only have EW, equivalent weight. But it's just the same because you are referring to the solute. Okay, that's AWS. Okay? But others, to be direct, AW only, and others EWS. But I prefer AWS because I want to include solute. Pwede ko maglibog kinabay solvent. Okay? Ganon. So AWS is equal to the grams. Okay? Equivalent. Grams equivalent. Okay. So, like this. So, 1 equivalent weight of solute is equals to 1 gram equivalent. Ganon. Okay. So, our technique for this, guys, is always use 1 mole of Arrhenius theory acidity, which is H plus, and 1 mole of Arrhenius theory of basicity. So 1 mole OH negative. Now, get the chemical reaction so that you can link the stoichiometric calculation in there, like that. So that we can come up with a gram, which is our 1 equivalent weight solute. So after that, we will substitute that here in this equation. Normality is equal to equivalent weight of solute over the liter. There's no such problem of the liter because it's mentioned that it is 850 milliliter of solution or 0.850 liter. There's no an issue of the volume here. Okay, only the equivalent weight of solute. Okay, now again, this is the reaction naman. Okay, calcium hydroxide positive, it will again calcium positive 2 plus twice OH negative. Ganon. So stoichiometric dimensional analysis. So since this is hydroxide, your first clue, this is computation for the normality of the basicity or basic substance. OH is an identification that this is a base. Okay? So use the 1 mole OH negative of Arrhenius theory of basicity. Oh, ganon. So, 1 mole, this is only conversion, ha? 1 mole of OH negative, okay? Okay, times, look at your reaction. How many mole of OH here in reaction? So it's obviously 2 moles of OH negative. Ganon. Cancel ang mole. Now, mga palangga, what is being asked, right, is calcium hydroxide. You will also take the moles of calcium hydroxide. Okay? Because you are doing that in parallelism of the OH. If you take the mole of OH, of course, you will also take the mole of the calcium hydroxide, which is being required. Alam mo, good kag mass, and you are talking with the moles. Okay? Dili ta muli ko. Liniki ko. Okay? We should put 1 mole calcium hydroxide. Okay? So that we have 1 mole of calcium hydroxide na siya pang mga palangga. So, 1 mole of calcium hydroxide. Now, what you will multiply so that we can obtain grams. Because our target is 1 equivalent with solute is equals to gram equivalent. So, meaning to say our answer will be gram. So, again, molar mass, chuva, chuchu. Again, this is a technique. If you get the mass and number of moles, it's always molar mass chuva chuchu. Okay? No other thing except for ideal gases that there are so much units there, you know, like constant temperature, like that, volume, pressure. But in this case, there's nothing. And this is not ideal gas in the first place. It's a solution. And it's not applicable here. So, mo gini yung kinangpan, molar mass. Okay? All the time. Basta stoichiometric guys, maugin na siya guys. Okay? So, 1 mole calcium hydroxide. So, mole ang denominator so that it will cancel the mole of calcium hydroxide. Okay? You get the point, mga palangga? Then the grams in the numerator. And this is the molecular weight of the calcium hydroxide. So, as far as I could remember, akong the-raise, 74.09. 74.096, and then cancel ang habilin grams. Take note. What's left is grams. So this is now the equivalent to weight solute. So 1 equivalent weight solute is equal to gram equivalent, in which this is the answer. But we still compute this one. Okay, this is the version 2. Okay, mga kapatid. Okay. Ako siya mag-iuna. I choose first normality because I hate normality before when I was in college. Okay? Namungot ako guys. Okay. So, 74.096. Okay. Then divided by 2 mga palangga. It's gonna be 37.048. 37.048 is our grams. So this will be our 1 equivalent weight solute. So this is 37.048 grams. So this is equivalent to the solute. Now, Sotero, we need to substitute that in the equivalent weight of solute. Just check also the problem that there is also a mass originally of calcium hydroxide. So it's impossible that that gram is not usable. There's a purpose for that. Then you have to do the, again, basic math, algebra, ratio and proportion. As I told you, it always going back, even though it's kind of college, third college, fourth year college. Okay, ratio and proportion because it has the same quantities, equivalent weight and the mass. Okay, it doesn't mention another quantities, so you will never use if there are a lot of quantities not parallel to each other. Okay, erase. Okay, para masunod ang atong mga explanations. Okay, ratio and proportion. Algebra 101. 6 units. Oh, 5 units. Okay. Okay. 1 equivalent weight solute is equal to 37.048 grams. Now, since we identify our EWS, okay, based on the calculation, and we need to know really our actual EWS, in which we don't know. Okay, so EWS, in which we don't know. Let X is the unknown, equivalent weight of solute. So put X. Nag-math na ta, guys. Okay, is equal to 50, no, it's not 50, sorry, this is 1.5. 1.5 grams. Okay? 1.5 grams. Okay. Ratio and proportion. 1 equivalent weight is 237.048 grams. X is 1.5. Okay, then math. X over 1.5 is equals to 1 over 37.048 mga palangga. So therefore, X is equal to this one divided by 1.5. Ganun siya. Okay? Ganun lang siya. Mathematics na kayo. Hindi siya lisulyan sa akin. Ano? There's no integration, differentiation, there's no limits. Okay? It's not differential equations. It's very easy to manipulate. And this is not even a polynomial. Okay? You get the point? Ganon. So, 1.5 divided by 37.048 is equals to 0.0404 mga palangga. So, 0.0404. And this is our grams equivalent weight of solute, in which we will substitute that in our formula of normality. Okay, not the 37.048 because we have still the grams data in our original question. Okay, we should use that. Okay, now 0.040 gram equivalent or equivalent weight of solute. Hindi mo na siya equivalent. Equal na siya. See, tinawag equivalent weight of solute is equals to grams. Since equal naman na siya, hindi mo na yung equivalent. Hindi mo na yung unit sa normality. So, equivalent, okay, liter of solution is 0.850. Be sure that in version number 2, we can obtain the same answer in version number 1, which is 0.0474, or else we are in error. Okay? Check mga palangga. Okay? Okay. 40 divided by 0.850. So the answer will be 0.475. Oh my gosh! 0.001 something lang siya. But acceptable siya talaga. Okay? For a second version, our normality is 0.0475. Okay? Like that ang normality. Now, if we go to the, again, math, how can we compute for the percentage difference in mathematics? You can still remember that one? We need to larger minus smaller over larger times 100. This is standard. So that we can determine the percentage error or percentage difference. So I will subtract this 0.475 to 0.474 over 0.475 times 100. This is what we call for the surveys, percentage of margin difference, like that. Okay, we can, so that we can compute what is the percentage difference of our answer. Ginuton pa siya dato na para may luman na to, diba? Okay, so 0.0475 minus 0.0474. Okay, divided by 0.0475 is equals to times 100. Oh my gosh! Only 0.2 is the difference. 0.2% is the difference. Acceptable, right? Okay, it's tolerable. Usually, plus and minus, 1, but it's lesser talaga siya. Okay? It's okay. So we go to version number 3, mga palangga. I have to erase this one already, mga palangga. Okay. Number 3, version number 3 na ta. Okay. Now in version number 3, I love this. Okay? This is my favorite, the number 3. Okay? Because in number 1, not all the time have molarity. And you have to still compute for the molarity. Okay? But here, I like this. The formula also is number of equivalents over the liter. So how can we compute for the number of equivalents? So the number of equivalents, mga palangka. Okay, this is the numerator of the normality formula. Number of equivalents is equals to the number of moles, small letter n, times the n factor. Charot. Nakaloka, n factor. The n factor unit is, okay, equivalent per mole. Okay, this is the n factor. Okay. Now, it's very easy for the number of moles, the same story that we've done before. Okay? And n factor, how can we do this? The n factor is basic also for the Arrhenius theory of basicity. Okay, again, maulagyan mo siya 2. Okay, 2 times negative 1 is equals to 2. So 2 ang replaceable OH. So, 2 na niya siya daan. Okay, so 2 equivalent per mole. Times the mole, in which we don't know yet, or klaro kung makasil ang mole o, ang very equivalent. Ang answer niya is a feature 22. Dire. Tada! Ganon. How can we compute for number was? Again, the same story. Okay? Like that. Kaloka. Diba? So, 1.5 grams of calcium hydroxide, and then, you know, molecular weight, gano'n. Okay, so 1.5 divided by 74.096. Actually, guys, we have already the value we solved before, the same as 1 and 2, but I erased. I'll just memorize, that's why. Okay? 0.0202. So 02.02 mole, because this is number of moles, times equivalent per mole, which is the unit of n factor. So cancel the mole, what left is equivalent. This is number of equivalent. So 2 times 02 times 02 is equals to, times 2 pa na siya mga palangga, ano? 0.0404. 0405. Okay, equivalent. So substitute that here. Okay, 0.0405, because this is the number of equivalents, over 0.850. Your answer must be closer to the 1 and 2, right? Because we are solving the same quantity, normality, right? Okay, so divided by 0.850 is equals to 0.476. Ay, nagkataas! Okay, 0.476. 0.476 normality or equivalent per liter. Actually, guys, if you encounter this in the choices in the examination, they will not give also very close, right? Or else they will force to put all of the above. Let's say, for example, in this question, A 0.0474, B 0.0475, C 0.476. It looks like also, you know, what do you call this one? Amazing. Only 0.001 something they put. Usually, not siya dako nga difference siya. Okay, but if very, very small difference, they put that there, then you will force to answer all of the above if only A, B, and C. But if until A, B, C, D, E, of course, we will say A, B, and C only, D, none of the above, E, all of the above. Your answer will be A and B and C only. Ang atong A, 0.0474, B, 0.475, C, 0.076, so A, B, C. So A, B, and C only, D, none of the above, E, all of the above. Because we are not sure, because there's a difference of 0.001, but actually this is correct. Okay? But I think they will not put this as a choices very close also. Okay? In my experience. Okay, charot. Okay. Any questions so far for this topic of normality, expression of the concentration? Okay. I discussed a while ago the dilution and concentration, right? The N1V1, N2V2, it looks very, you know, tasky. It's not difficult, guys, only tasky. And you have to be patient. The more you are not patient, the more you cannot get the correct answer. Because the more you are not patient, the more you always keep on erasing the data and it will confuse your eyes. The error will be there. Not only, it doesn't mean you don't know how to solve already, but the way you do the solutions, you take it so fast and then you're taking for granted the small error and in the end it will become the whole error. Okay, like that, and then you forgot to cancel the units. Okay, like that, and the zero also, when zero zero something, you put only one zero. Things, there's a lot of things to be considered now. Okay, actually, okay, like that. Okay, thank you so much. If you like and comment this video, you can do that in the comment section. You can subscribe to my channel if you haven't yet subscribed. Wow. And then you can also click the notification bell for some news updates. And I am a singer, Eternal Voice, all about Zion's vlogs. For now. Okay, for now talaga. Okay. So wait for my next vlog. We will be tackling, I think we will be tackling. We will go to molality or we still have another example of normality. So it depends. Kimukakon sa kuog, kuan. Char! Kaloka. Bye-bye. God bless everybody, mga palangga. Bye-bye. God bless.